Chapter 11. Arctic Peoples. 1. Intelligence of Arctic Peoples. 2. Visual memory. 3. Brain size. 4. Genotypic intelligence of Arctic peoples. He Arctic peoples are the indigenous Inuit of Alaska, the north coast of Canada, and Greenland, the Aleuts of the Aleutian Islands, and the North Turkic and Chukchi peoples of the far northeast of Asia. They are identified as a distinctive genetic cluster by Cavalli Sforza, Manozzi, and Piazza in their classification of peoples based on a number of genetic markers. The Arctic peoples differ genetically from the Amerindians in having an appreciable percentage of the B blood group, which is absent in the Amerindians. They differ from the Amerindians and from the East Asians in that they are more highly cold-adapted, with shorter legs and arms and a thick trunk to conserve heat, a more pronounced epicanthic eye fold, and a nose well flattened into the face to reduce the risk of frostbite. The reason the Arctic peoples have evolved into a distinctive race is that their ancestors were isolated from the East Asians by the Chersky mountain range in Northeast Asia. The Inuit split off from the Chukchi people of northwest Russia when they migrated across the Bering Straits into North America about BC 11 to 10,000. Several of their prehistoric sites have been found in the Nenana River Valley in central Alaska, where their artifacts have been dated at between 11,300 to 10,000 years ago. In the mid-20th century, there were approximately 50,000 Inuit and approximately 500-600 Aleutians. 1. Intelligence of Arctic peoples. Studies of the intelligence of Arctic peoples are summarized in Table 11.1. Row 1 gives an IQ of 89 for the first study of a large sample of Inuit children tested with the Good Enough Draw a Man test. Row 2 gives an IQ of 92 for a sample of Aleutian children also tested with the DAM by the same author. This is the only study of the intelligence of Aleutian children. All the other studies are of Inuit. Rows 3 and 4 give results of a study of the IQs of representative samples of primary and secondary Inuit school children in the Yukon and Northwest Territories of Canada tested in 1962. The primary school children obtained an IQ of 94, and the secondary school children an IQ of 84. Row 5 gives the lowest IC of the series of 78 for a sample of young adults and is so much out of line with the other results that it should be regarded as spurious. Row 6 gives Inuit adults a visualization IQ of 93. Row 7 gives an IQ of 91 for 10-year-olds. Row 8 gives an IQ of 90 obtained by Vernon from tests of matrices, vocabulary, and Coe's blocks. The low IQ of 80 per vocabulary may be spuriously low because the children may have spoken their native language at home. The IQ of 90 for reasoning has been entered as the most reasonable figure for general intelligence. In this study, Vernon also gave the DAM test, on which the Inuit children obtained an IQ of 95. This is broadly consistent with the results in rows 1 and 2, in which Arctic children obtained DAM IQs of 89 and 92. Row 9 gives an IQ of 91, for a substantial sample of 6 to 12-year-olds obtained from the performance scale of the WISC. These children obtained much lower verbal IQs, but they did not speak English as their first language and their low verbal IQs cannot be regarded as valid. Row 10 gives a reasoning IQ of 96 for a sample of 9 to 12-year-olds. Row 11 gives verbal and performance IQs of 78 and 93 respectively for a small sample of 7-year-olds tested with a WPPASI. The children spoke English as a second language, so the verbal IQ is spuriously low, and the performance IQ of 93 is entered as the best measure of general intelligence. Row 12 gives a reasoning IQ of 95 for a sample of 7 to 10-year-olds. Row 13 gives an IQ of 91 for a substantial sample of 7 to 14-year-olds obtained from the performance scale of the WISC-R. The verbal scale was not given because the children did not speak English as their first language. Row 14 gives an IQ of 92 for Inuit 5-year-olds living in Arctic Quebec. The authors claim that the Inuit children scored higher than Americans, but this is because American norms are depressed by the inclusion of ethnic minorities. And because they made no allowance for the secular increase of scores, the children were also given Repeated testing at the ages of 6 and 7 in which they made gains attributable to practice effects. Row 15 gives a nonverbal reasoning IQ of 86 and a vocabulary IQ of 77 for Inuit 15-year-olds in Alaska. The median IQ of the studies is 91 and is proposed as the best estimate of the intelligence of the Arctic peoples. The visualization IQs are somewhat higher than the verbal IQs, as shown in Vernon's sample given in row 8, where the visualization IQ is 88 and the verbal IQ 80, and again in the Taylor and Skane study given in row 11, where the visualization IQ is 93 and the verbal IQ 78. Averaging the two results gives a visualization IQ 11 points higher than the verbal IQ. This high visualization, low verbal pattern is also present in the related East Asian and Amerindian peoples. It appears that there has been no tendency for the intelligence of Inuit to improve over the period of approximately 60 years from the early 1930s, when the first study by Eels found an IQ of 89, to the last study in the early 1990s, when Wilgosh et al. Found an IQ of 91. 2. Visual memory. The Inuit have an unusually strong visual memory ability that is not measured in standard intelligence tests. This was shown by Kleinfeld in a study of the visual memory of 125 Inuit village children in Alaska aged 9 to 16, compared with 501 white children in Anchorage and Fairbanks, the two principal towns in Alaska. The test consisted of the presentation of drawings for a brief period of time, after which the children were given the task of drawing them from memory. The Inuit children obtained a mean IQ of 106 in relation to a white mean of 100. Kleinfeld observes that this test result is consistent with the observations of travelers who have accompanied Inuit on long hunting expeditions. She writes that Caucasians who have traveled with Inuit frequently remark on their extraordinary ability to travel through what seems to be a featureless terrain, by closely observing the smallest landmarks and memorizing their spatial locations. The strong visual memory of Inuit may explain why they are relatively good at spelling. In Vernon's study, he found that Inuit 10-year-olds had a spelling IQ of 95, considerably higher than their verbal IQ of 80. Of which spelling is generally considered a component. Good visual memory helps spelling because it makes it possible to recall the shapes of words. This is probably why females are much better at spelling than males. They have better visual memories. It is likely that the strong visual memory of Inuit has a genetic basis. It has been found by Osborne and Gregor that visual memory has a high heritability. Even 9-year-old Inuit children had significantly better visual memory than Europeans, and it seems unlikely that children of this young age would have acquired this strong ability through training, even if this is possible. The most probable explanation for the strong visual memory of Inuit children is that this ability developed genetically through natural selection because of the need for Arctic peoples to remember fine details of the landscape in order to find their way home. After going out on long hunting expeditions, the landscape of the frozen tundra provides few distinctive cues, so hunters would need to note and remember such few features as do exist. The strong visual memory of the Inuit is also present in the East Asians and Native Americans, for whom Lombardi found an IQ of 104, very close to the IQ of 106 found by Kleinfeld for Inuit. Possibly the ancestral population of Northeast Asia evolved strong visual memory before they diverged into the East Asians, Native Americans, and Arctic peoples. The strong visual memory of the Inuit has a parallel with that in the Australian Aborigines, reported by Cairns, and explained as an adaptation to living in deserts with few landmarks and similar in this regard to the frozen tundra of the Arctic. 3. Brain size. It is only proved possible to find one study of the brain size of Arctic peoples. Smith and Beals give brain sizes for 10 populations of which the mean is 1,444 cc. They give a brain size for Europeans of 1,368 cc. The difference of 76 ccs is substantial. Brain size is associated with intelligence among individuals, and the same association would be expected to hold between groups. The larger brain size of the Arctic peoples leads to the expectation that they would have higher IQs than Europeans. Yet this is not the case. There are two probable explanations for this anomaly. First, some of the large brain size of the Arctic peoples is likely devoted to their strong visual memory found by Kleinfeld and summarized in Section 2. Second, brain size is not the sole determinant of intelligence. Some neurophysiological processes for higher intelligence may have evolved in the Europeans as a result of genetic mutations, but failed to appear in the Arctic peoples. The reason for this is probably that the Europeans were much more numerous, so that the chances of favorable mutations for greater intelligence were greater. 4. Genotypic intelligence. It seems probable that both genetic and environmental factors contribute to the low IQ of the Arctic peoples. There are two lines of evidence suggesting some genetic determination. First, as noted in Section 1, the IQ of the Arctic peoples has not shown any increase relative to that of Europeans since the early 1930s, although their environment has improved insofar as in the second half of the 20th century they received improved welfare payments and education. If the intelligence of the Arctic peoples had been impaired by adverse environmental conditions in the 1930s, it should have increased by the early 1980s. Second, in all the studies summarized in Table 11.1, the Arctic children were at school and thus familiar with test-taking procedures, so there is no reason to suppose that they were handicapped in this regard.